Welcome to Chapter 14, Consumer Surplus. Before we dive into this chapter, I want you to take careful note that Hal has labeled this chapter as Consumer's Surplus. So this is in the singular possessive. What this means literally is that we are interested in the surplus of a single consumer. We're not interested in the surplus of consumers in general, in the plural sense. We are interested in the surplus of a single individual consumer. Okay? So, in Intro to Microeconomics, consumer surplus was represented as the area underneath the demand curve. So this would mean, since in Intro to Micro, demand curves were market demand curves, this represented the surplus that accrued to multiple consumers, and there were other inaccuracies to this simplistic view, and Varian gives them here. The first one is that the demand curve, so the area underneath the demand curve would represent consumer surplus in the plural only if the demand curve is compensated to eliminate income effects. You remember in Chapter 8, when we talked about the Slutsky equation, we introduced this idea of the Slutsky or compensated demand curve. And what that did is, when there was a price change, we derived a demand function in which the consumer's purchasing power was kept constant. So this would be, and in so doing, we eliminated income effects. So this would be one way to ensure that the area underneath the demand curve really did represent changes in surplus. The other possibility would be that we use demand curves constructed from utility that does not have income effects. And you remember from earlier chapters, we established that quasi-linear utility did not have income effects for the nonlinear good. So to simplify analysis in this chapter, Hal is going to make the heroic assumption that all examples are based off consumers that have quasi-linear utility. Not terribly realistic, but it'll make our lives mathematically much easier. So we'll do it happily. So let me review really quickly this idea of reservation prices. I believe we first introduced this in Chapter 6, if I remember right. So quasi-linear utility, remember, is a utility function that is nonlinear in one good and linear in another. So in this particular example, let my utility be nonlinear in x1, and I've tried to represent that in generality with the Greek letter nu. So that kind of funky looking V is the Greek letter nu. So nu sub x1 is some nonlinear function of x1. And if you think back to examples that we've seen in the quizzes, popular ones we've used would be the square root of x or the natural log of x. There are others, but those would be, or we actually have had ones where we've had utility as a quadratic function of x. So there's x1 and x1 squared. So in this case, the reservation price is defined as the price that makes the consumer indifferent between not consuming any of this good and having the entire budget left over to spend on x2, or having one unit of x1 and spending the top dollar. So if I spend my top dollar or my reservation price, that means I have M minus R1 dollars available to spend on good 2. So if I substitute in the functional form of utility, the utility, if I consume no x1 and M, and let's say that x2 is dollars to be spent on the other good, just to make things easy. My utility then would be nu sub 0 plus M, and that must equal nu of 1 plus M minus R1. You'll notice that M the income level cancels out from both sides, and through rearrangement, I find that the reservation price of good 1 is equal to new 1 minus new 0. I can extend this analysis to find the reservation price for good 2. You recall the way I can do that is if I bought 1 unit of the discrete good and paid my reservation price for it, my utility must be the same as if I bought 2 units of this good and paid the reservation price for each unit. So now I have multiple things that cancel out, M and R1, and what I'm left with is R2 is equal to new 2 minus new 1. Well, this is a pattern, and we can state then that the reservation price for the ith unit of consumption must be the nonlinear function applied to good I minus the nonlinear function applied to the previous unit of consumption, I minus 1. So to apply this, consider my gross surplus for consuming Vinny lattes. So let my utility function for Vinny lattes be 10 square root 1 plus x2. So if I apply the formula that I derived from the previous slide, my reservation price for the first Vinny latte is 10 root 1 minus 10 root 0, or I'd be willing to spend up to $10 for the first Vinny latte. I'd be willing to spend $4.14.2 for the second latte, and then my reservation price continues to decline. The idea of drinking 5 Vinny lattes is really kind of scary. So if we add all these reservations prices up, what that gives me then is what Varian describes as gross consumer surplus. So what that says is that if I were to buy and drink 5 Vinny lattes, I'd never sleep for 3 days, but the value that I would place upon consuming those 5 would be $22.36. That's the sum of my 5 reservation prices. So what that means then is I would be indifferent between consuming 5 Vinny lattes for $22.36 or no Vinny lattes and having all my money to spend on other goods and services. Net consumer surplus is the difference between what I was willing to pay for a Vinny latte and what I actually did pay. So suppose that I can buy Vinny lattes for $4 each. So my net consumer surplus then of the first Vinny latte, I'd be willing to pay $10 for up to $10 for the first Vinny latte that I consumed. I only have to pay $4. So what that means is the green shaded region just above me to the left shows that if I bought 1 Vinny latte for $4 and I drank it, I am made better off by $6 cash equivalent. Right? So being able to buy a latte for $4 and drink it makes me as much better off as if someone gave me an additional $6 to spend on other goods and services. My second Vinny latte, my reservation price was $4.14. So what that means is if I buy a second one at $4 and drink it, that makes me better off by a net amount of 14 cents. And since my reservation price is less than $4 for each additional latte, I would not buy more than 2 lattes. Okay. So an alternative way of thinking about net consumer surplus is I'd be willing to give up drinking if someone offered me $6.14. Right? So the ability to buy lattes at $4 and drink as many as I want makes me better off by $6.14. Someone would have to offer me $6.14 to quit before I'd be willing to accept this. So it's been lots of fun developing consumer surplus, but Hal has bad news for us. The calculation of consumer surplus actually has limited practical application because we had to impose such strict assumptions to make it accurate as a measurement of well-being. So the way that you do see sometimes consumer surplus used is changes in consumer surplus can be used as a measurement of how a policy affects consumer well-being. So for instance, if the government raised taxes on gasoline, the change in consumer surplus, or the change in net consumer surplus, would be a measurement of how much consumers are harmed by the imposition of higher gasoline taxes. So the assumptions necessary to make this accurate are rather heroic, and it turns out we have two other tools that are more useful and don't require these same strong assumptions. So they're compensating variation and equivalent variation. And what both of these do is they put a cash value on the effect of the policy change on consumer well-being. And we don't have to make these restrictive assumptions that we did to calculate net consumer surplus. Compensating variation computes the change in income necessary to compensate or restore the previous level of well-being. When I hear the word compensation, I think of all the commercials that I see on TV for personal injury attorneys. They talk about how we will receive compensation. Have you been hit by a truck? Call our law firm and we'll make those truck companies pay. We'll make you as well off as you were before. So if you, God forbid, were in an accident, you got hit by a truck, you have to call this law firm. What they're going to do is they're going to bring it to court, and the argument that the personal injury attorney makes before the jury is, these are the damages that happened to my client, and my client needs compensation to restore them to the level of well-being that they were at before. That's compensating variation. So it is a backward-looking or an ex post concept, meaning that the accident has happened, right? So the truck hit me. And the question is, how do I restore the previous level of well-being? Or in a policy sense, what we would say is, the government has increased my gasoline taxes. It's already happened. How do we restore? How much cash do I need to restore my previous level of well-being? The equivalent variation is, by contrast, a forward-looking or ex ante calculation. What this says is it computes how much of a change in income would be considered equivalent. So if the government is talking about increasing gas taxes, so it's a possibility, it hasn't happened yet. How much cash would I lose? So what drop in income would I consider equivalent to if the government increased my taxes? So forward-looking or ex ante. The tax increase is equivalent to a $50 loss in income. That's an equivalent variation. Okay, so here we have it. The government increases, they impose a gas tax, so the budget line for gasoline shifts inward, or it pivots inward, and my gasoline consumption falls from G sub 0 to G sub 1. To calculate the compensating variation, what this says is the government has increased my gas taxes. How much income do I require to compensate me or to make me as well off as I was before? So if the government has increased gas taxes, what that means is the budget line has become steeper. So I think about this new blue imaginary budget line, which now intersects my original utility level U sub 0. So where the blue budget line is tangent to U sub 0, that restores my original level of well-being. So the dollar amount that goes from my original income to this new level that's represented by the vertical intercept of the blue line with the vertical axis, that distance there is my compensating variation. Okay. The equivalent variation says that I'm sitting at my original prices. The state of Texas has announced that they're thinking about increasing gas taxes by 50 cents. The way you could think about this is, how much would I be willing to pay to a lobbyist to ensure that this gas tax doesn't come into, it isn't enacted? That's what an equivalent variation is, right? So the blue imaginary budget line is the same slope as my original budget line before the tax increase. So we bring it down, it intersects U sub 1, this lower level of utility, the utility that I've had after I've been damaged by the state's tax increase. And the question of equivalent variation is, how much money would the state have to take away from me and leave the price of gasoline unchanged to hurt me as much as an increase in gas taxes? That's the equivalent variation. Okay. So here's the contrast between them. Remember, compensating variation is ex post. This says, how much money do I have to get to restore my previous level of well-being? Equivalent variation says, if the policy change has not yet been enacted, how much of a change in income would I consider equivalent to the same change in utility as this policy would cause? You can see from this diagram that even though they sound kind of similar, the dollar amount of compensating variation and equivalent variation are usually different. So be careful that you're calculating the right one. So I'm going to show you examples or implement compensating and equivalent variation with the quiz questions. Okay? So first, though, I'm going to do a consumer surplus problem. We have Miss Quasimodo, who consumes earplugs and has dollars left over to spend on other things. And if the price of earplugs rises from $50 to $80, how does that affect Ms. Quasimodo's consumer surplus? So the first thing we need to do is come up with her demand function. All we had was a utility function. So to get Ms. Quasimodo's demand curve, what we need to do, she's quasi-linear, okay, so Quasimodo, right? Quasi-linear. So we set the slope of her indifference curve equal to the slope of her budget line. So we do that, right? I show first the slope in her indifference curve, then the slope of her budget line, which is negative p. So we set the slope of her indifference curve equal to the slope of her budget line, and we get a demand function for earplugs for Ms. Quasimodo. And it turns out it's a very simple linear demand curve. So we can easily chart Ms. Quasimodo's net consumer surplus if the price of earplugs was $50, right? She consumes 50 earplugs. If the price of earplugs rises to 80, she will consume 20 earplugs. And we can compute the change in the area of those green triangles from the big one to the small one, and that represents the change in Ms. Quasimodo's net consumer surplus. Okay? So compensating and equivalent variation were introduced to Bernice, who consumes earrings and has dollars left over to spend on other things. And to Bernice, earrings and dollars to spend on other things are perfect complements. So she has to consume them in fixed proportions. And then we hit Bernice with a increase in the price of earrings and want compensating variation. So what we need to do then is first calculate her initial choice. So since this is perfect complements, what we know is Bernice's choice will be the spot where the kink on her indifference curve intersects the demand curve. So intersects her budget line. So we have the equation of her budget line, 5x plus y is equal to 18. We know that the kink happens when x is equal to y. We make that substitution into her budget equation, and then we get that she buys 3 earrings and has $3 left to spend on other goods and services. Then, to get the compensating variation, what we have to do is figure out how much income do we have to give Bernice to restore her to her original level of well-being after the price increase has taken place. Now, it turns out that to calculate compensating variation, we actually don't even care what Bernice's consumption choices are after the price increase happened. All we care about is her initial consumption point, and then giving her enough money to get to that same initial consumption point. So we find out how much it would cost Bernice to afford her original bundle at the new prices. It would be $27. She originally had $18 to spend, so Bernice's compensating variation is $9. You notice that this was greatly simplified because of perfect complements. Now, at the very end of this lecture, I'm going to show you the more complicated example, but appreciate here the simple example. All we had to do to restore her previous level of well-being is give her enough money to hit her, or to be able to afford her original consumption point at the new prices. She needed $9. Okay. And now we have Bernice revisited. She has different prices and different income levels, and now we want Bernice's equivalent variation. Okay. So to get the equivalent variation, it turns out we don't care about her initial consumption choice. We only care about her final consumption choice. So to get her final choice, what we do is we plot her budget line after the price increase. So after earrings now cost $5 a pair. The information about the kink was where x is equal to y. We substitute that into the budget line, and we're able to find that after the price increase, Bernice will buy 5 pairs of earrings and have $5 left to spend on other goods and services. To get the equivalent variation, what we need to do is figure out how much money we had to take away from Bernice such that she would choose 5.5 at her original prices, right? So how much money do we, remember the equivalent variation was how much money do we have to take away from Bernice to hurt her as much as this price increase? So the way to do that is we have to take away enough income from Bernice such that she will choose 5.5. So we find out what it would cost to buy 5 earrings and have $5 left over when earrings cost $4 a pair. She would need $25. She originally had 30, so what we know then is that the price increase hurts Bernice as much as if she were to lose $5 of income. Okay. Now, the final example, I wanted to show you compensating variation for Cobb-Douglas utility. The reason why I wanted to show you this is in the SmartWorks homework that I've also assigned for this chapter, I'm asking you to do equivalent variation for Cobb-Douglas utility. So compensating variation and equivalent variation are similar but not identical. I wanted to show you this example with compensating variation just to show you the differences that you'll encounter with Cobb-Douglas utility versus perfect complements. So you'll be able to figure out then how to do the SmartWorks homework. Okay. So step one, we solve for the utility level before the price increase happens. So in this case, we had an initial choice, right? And that's the dot on curve U sub 0. We have a price increase that causes consumption to fall. Compensating variation, you remember, was how much money do we have to give back to this consumer to restore their original level of well-being. What's different now is we don't give them enough money to restore their original choice. You remember back to chapter 7 where Varian talked about Social Security. If we give this consumer with imperfect substitutes enough money to afford their original consumption choice, they're actually made better off. Compensating variation computes how much additional income restores the original level of well-being. So we need to find the amount of income that would restore this consumer to a utility level of U sub 0. Okay. So the first part of that is figuring out what U sub 0 is. So given the given the utility function that we have, x1 to the 0.25, x2 to the 0.75, what we know is that this consumer will spend 25% of their budget on good 1, 75% of their budget on good 2 by the exponent rule. So given prices for good 1 and good 2 and income levels, it's very straightforward to figure out what the consumption level of good 1 and good 2 is. So they're going to spend, so what I've done here actually, I guess I've been a little more mechanical in my computations. I've given you actually the demand function for x1. It's 0.25 m divided by p1. Or if you wanted to just reason through this at a higher level, I know that this consumer is going to spend 25% of their budget on good 1. That's $50. And if so they spend $50 on good 1 costs $2 for each unit. That means they're going to spend $25. They're going to purchase 25 units of X1. And that's what we get from substituting values into the demand function as we've derived it before. In much the same way, this consumer is going to purchase 150 units of good 2. So we put 25 and 50 into the utility function and find out that the utility level is going to be 95.84. So what we need to do, step 2, is we need to solve for a new income level which will give us a utility level of 95.84 at the new prices. So I start in the column right above me with the utility function, and I set that utility level to 95.84. And what I've done is I've substituted for x1 the demand function. So the demand function for good 1 is 0.25 times the new income level divided by the new price level. And then substituted for x2, the demand function for x2 at the new income level and at the unchanged price. Okay. So then going from the second line to the third line, I've substituted in prices. The price levels are 3 for good 1, and the price of good 2 remains fixed at 1. and then it becomes manipulation time. So as I simplify that expression, I'm able to recover m prime and then have some ugly stuff preceding it, which through using my calculator, I get to 0.433. And if I know that 95.84 is equal to 0.433 m prime, through simple rearrangement, I find m prime is 221.34. So the compensating variation is this new level of income. This, remember, so new level of income minus original level of income. Compensating variation is $21.34. So what this is saying literally is this consumer needs $21.34 of additional income to restore the original level of utility after suffering loss from the price increase. Let me state it again very carefully. We did not give this consumer enough money to afford their original consumption point. We gave them enough money to restore their initial utility level. So that's a very important difference. So remember that when you go to the SmartWorks homework. Okay? So that'll do it for chapter 14.